It's 2 a.m. on a Tuesday. Your phone rings. Your monitoring system has triggered an alert. Something is wrong with the payment service. Thousands of transactions are failing. You open your laptop, pull up the database, and query the service status table. The column is called status. The value is 2. What does 2 mean? You don't know. The engineer who wrote this system left the company 8 months ago. There is no documentation. There is no comment in the code. There is just a number, 2, sitting in a column called status, telling you nothing at all. While thousands of transactions continue to fail. You start guessing. Does 2 mean running, degraded, maintenance, error? You check the application code. You find conditions like, if status is equal to 1, if status is equal to 3, if status is not equal to 0, what is 0, what is 1, what is 3? You find a comment from 4 years ago that says 2 okay. You find code written 2 years ago that treats 2 as a warning state. You find a third interpretation in a config file that has never been updated. The system has been running for 4 years. In that time, status 2 has meant 3 different things, to 3 different parts of the same application. Nobody noticed because when everything was working, the exact meaning of 2 didn't matter. It matters now. This is the magic number problem, and it is one of the most widespread, most quietly destructive patterns in production databases. A magic number is a numeric value stored in a database that carries meaning only inside the head of the person who created it. It isn't a measurement, it isn't a calculation, it's a code, a symbol that stands for a concept, but the dictionary that translates it was never written down, or was written down once and then diverged from reality, as the system grew and changed around it. Status columns are the most common home for magic numbers, but they live everywhere. A priority column where 1 means high, 2 means medium, 3 means low, until a new developer joins and assumes, reasonably, that higher numbers mean higher priority. An order type column where 0 means standard, 1 means express, 2 means international, until a third-party system integrates with the API and interprets 2 as cancelled. A user role column where 1 means admin, 2 means user, 3 means guest, until the product team adds a new role. Someone picks 4, someone else picks 5 for a different new role in a different service, and now 2 services disagree about what 4 means. In each case, the data is technically valid. The database accepted it. No constraints were violated. No errors were thrown. The number is there, correctly stored, precisely wrong. Let's look at a real pattern. In 2021, a mid-sized logistics company experienced a cascade failure across its delivery tracking system. The system used a numeric status column to track shipment state, 1 for pending, 2 for in transit, 3 for delivered, 4 for failed. 2 years earlier, a developer had added a new state, shipments held at customs. Rather than updating the data dictionary or using a new migration, they reused status 4 because the old failed state was being deprecated. They updated the application code in 2 of the 3 services that read the status column. They missed the third. The third service, the customer notification system, continued reading status 4 as delivery failed. For 2 years, every shipment held at customs triggered an automated email to the customer saying their delivery had failed. The emails went out correctly, reliably, without any errors in the logs. The system was working exactly as it was written. It was written against a definition that no longer existed. The company discovered the bug when a large client noticed that their customs-held shipments were generating failure notifications. An audit revealed that over 90,000 incorrect emails had been sent over 26 months, not because of a system crash, because a number silently changed its meaning, and one service never got the update. Magic numbers don't just cause confusion during incidents, they cause silent, sustained, long-running failures that look completely normal in the logs. Now let's go deeper into why this happens. When a system is first built, magic numbers feel reasonable. There are only 3 states. Everyone on the team knows what they mean. Writing 1, 2, 3 is faster than writing a string. Numbers are more efficient to store. Numeric comparisons are faster than string comparisons in large tables. These are real, legitimate technical reasons. The problem isn't the initial decision. The problem is that meaning is fragile, and numbers don't carry their meaning with them. A string column storing in transit carries its meaning inside itself. You read it and you know what it represents. A numeric column storing 2 carries no meaning at all. The meaning exists only in the application code the documentation, and the shared understanding of the team, all of which change over time, diverge from each other, and are never perfectly synchronized. And teams change. The person who designed the status codes leaves. The documentation gets outdated, but nobody updates it. A new developer makes a reasonable assumption that turns out to be wrong. A third-party integration reads the column without access to the internal documentation. A new service is added and its developer reads the existing code, finds 3 examples of how status is used, and misses the 4th that contradicts the pattern. The number stays the same. The system around it shifts, and the gap between the number and its meaning widens until the meaning is effectively gone, leaving just a number in a column at 2 a.m. on a Tuesday, when everything is broken and you need to know what it means right now. So what does good look like? The first and most important change is to replace numeric codes with named constants in your application code. Don't write if status is equal to 2. Write if status is equal to status.intransit. The constant status.intransit has a value of 2. If the value ever changes, you change it in one place. And when you read the code 6 months later, you know immediately what you were checking. The number becomes an implementation detail. The name becomes the truth. The second change is to use enumerations at the database level, where your system supports them. An enum column that accepts only pending, in transit, delivered, failed, cannot store 2. It cannot store 7. It cannot store a value that has no meaning. The database enforces the vocabulary, not just the type. A new state requires a deliberate schema change, a migration, a code review, a documented decision, not a developer quietly repurposing an existing number at 11 p.m. before a release. The third change is to treat any addition to a status vocabulary as a migration event, not a code change. When you add a new state, you update the database schema, the application constants, every service that reads the column, and the documentation, at the same time, in the same release. Not because you have to, because the cost of a partial update is an OAM incident 2 years from now that nobody can diagnose, because the person who made the change is no longer at the company. The fourth change is to audit your existing magic numbers before they audit you. If you have a column called status, type, flag, mode, or code that stores integers, look at every value currently in production. Find every place in the codebase that reads or writes that column. Check whether they all agree on what each value means. Do this before an incident forces you to do it under pressure. The deeper principle underneath all of this is one we keep returning to in this series. Data without meaning is not data. It's noise with structure. A database can store any number you give it. It has no way of knowing whether that number represents a valid state, a deprecated state, a misunderstood state, or a state that 3 different services interpret differently. The database's job is to store values reliably. The meaning of those values is your responsibility, and meaning requires maintenance. It requires documentation that lives next to the data. It requires that every person who reads a column has access to the same definition as the person who wrote it. It requires that adding a new value is treated with the same care as adding a new column. A number in a column called status tells you nothing about the state of your system. It tells you what someone decided to store at the moment they wrote the code, in the context they were working in, with the assumptions they held at the time. All of those things change. The number doesn't. And at 2 a.m. on a Tuesday, that gap is the entire problem.